This is a Cambridge IGCSE Physics Paper 2 talk through which measuring devices are most suitable for determining the length of a swimming pool and the thickness of aluminium foil. So try and be sensible here. A swimming pool is quite long. You'll want a tape measure because it's long and flexible. And then the thickness of aluminium foil, it's going to be very thin, so micrometer screw gauge would be most suitable here. The answer is B. A man stands next to a railway track. A train travelling at 40 metres per second takes 2 seconds to pass the man. What is the length of the train? Here's your formula. So you want distance is speed times time. So 740 times 2. The answer is 80 metres. The speed time graph is used to describe the motion of an object. Which quantities are calculated from the gradient of the graph and from the area under the graph? So pretend there's an example. So the gradient would be change in speed, because it's the y-axis, divided by time, which remember is the same as acceleration. Acceleration is change in speed over time. So we know the gradient is acceleration, and then you just need to remember for me that the area under the graph is the distance travelled. The answer is A. On the moon, all objects fall with the same acceleration. Which statement explains this? On the moon, all objects have the same weight. The moon has a smaller gravitational field strength than the Earth. No, the weight of an object is directly proportional to its mass. That is absolutely true. The answer here is C. A measuring cylinder contains 30 centimetres cubed of a liquid. Some more of the liquid is added until the liquid reaches the 50 centimetres cubed mark. The reading on the balance increases by 30 grams. What is the density of the liquid? So density is mass over volume. The mass is 30 grams. The volume has increased by 20. So the answer is 1.5. An object at the end of a string moves in a clockwise circular motion at constant speed. The diagram shows the object viewed from above. What is the direction of the resultant force in the object when it is in the position shown? So this object's moving in this direction. It's got a centripetal force acting on it, which will keep it moving. Remember, the force will always be acting towards that centre, so the answer here is A. A beam is pivoted at one end as shown. So I already know this question is about moments. The beam weighs 6 newtons and its weight acts at a point 40 centimetres from the pivot. A force of 4 newtons is applied to the beam, causing it to balance horizontally. In which direction and where is the force? Lyra, you're being very noisy. A force of 4 newtons is applied to the beam, causing it to balance horizontally. In which direction and where is that 4 Newton force applied? The key thing here is that the pivot is over here. Then compare the force being applied versus the force from the beam's weight. It's a lower force, so remember, to increase the size of the moment or turning force, you need a longer distance, perpendicular distance from pivot, which means we want that force applying to the right of x, and it needs to be in the opposite direction, which is why it's upwards. D. On the diagram shown, what is the magnitude of the resultant force of the two vectors? So you can use a ruler to measure this distance, or you can use Pythagoras' theorem, which is a squared plus b squared equals c squared. So that becomes 6 squared plus 8 squared equals c squared. So the answer here is 10 newtons. So it's up to you whichever way you prefer to calculate that. 3 situations are listed. An object has a resultant force acting on it. A moving object experiences an impulse. An object is decelerating. In which situations is the momentum of the object changing? Hopefully you're happy that it will be actually all 3, because of course the momentum of the object will be changing if it has a resultant force acting on it, if it's experiencing an impulse, and if it's slowing down. A ball of mass 0.16 kg is moving forwards at a speed of 0.5 meters per second. A second ball of mass 0.1 is stationary. The first ball strikes the second ball. The second ball moves forward at a speed of 0.5. What is the speed of the first ball after the collision? Let's draw some pictures. So here's our first ball. It's moving at 0.5 meters per second. It has a mass of 0.16 kg. Here's our second ball. It's got a lower mass and it's stationary. And then post-collision, we can see the following, that the second ball with the mass of 0.1 kg moves off at a speed of 0.5 meters per second. The first ball still has a mass of 0.16 kg, but we're being asked to find its final speed. So the way we do this is we write momentum before equals momentum after. So the momentum before is the mass of the first ball times its speed, plus the mass of the second ball times its speed. But look, you're timesing 0.1 by 0, which means it equals 0. So what's the momentum after? Well, it's the mass of the second ball times its speed, plus the mass of the first ball times its speed. And that's the x value we're after. So now to work out the left-hand side, 0.16 multiplied by 0.5 is 0.08 equals 0.05 plus 0.16x minus 0.05 from both sides, and then divide both sides by 0.16 to find x, to get 0.1875, which is the same as to two significant figures, 0.19. That was a lot of working. A mass hangs vertically from a spring. The mass is raised to a point P and then released. The mass oscillates repeatedly between point P and a lower point Q, which energies alternately increase and decrease throughout the oscillations. So we're going to have, because we have a spring, we're going to have elastic energy. Because it's at height, you're going to have a gravitational potential energy, and because it's moving, you're going to have kinetic energy. The answer is A. A car has 620 kilojoules. Let's get that into joules straight away. Of kinetic energy. The car brakes and stops in a distance of 91 meters. What is the average braking force? This is the formula triangle you need this time. So force is energy divided by distance. So the answer is 6813. To two significant figures, the answer is C. The diagram shows a deep reservoir formed by a dam. On what does the pressure X depend on? Remember, this equation states that pressure difference equals height times density times gravity, so the answer here is the depth of water. A sealed rigid container has a fixed volume. The container is filled with air. The container is placed in a freezer cabinet and the temperature of the air in the container decreases. What row correctly describes what happens to the air in the container? So as that container air gets colder, it means that the air particle speed will decrease. But because all the particles have decreased in speed by the same amount, it won't change the distance between the particles, so the answer is D. Two open containers are filled with water at room temperature. The containers have different shapes. From which container does the water evaporate at a greater rate, and how can the rate of evaporation be increased? So the surface area here is greater for container 1, so I'd expect evaporation to take place faster here. And then how can we increase the rate of evaporation? Well, we want the temperature gradient to be as large as possible. So we want this to be as hot as possible, this to be as cold. So we would increase the water temperature, 15B. The diagram shows a liquid and glass thermometer. A student wishes to check the marking of the upper fixed point on this thermometer. What should she do? So we want to really raise that temperature, and we want to do that using pure water. So the answer is B. Water in a beaker contains thermal energy at a rate of 3000 watts. The water is at its boiling point. The specific latent heat of vaporization of water is this. How long does it take for 250 grams of the water to vaporize? So first of all, we need to find out the energy by doing the mass of the water, which is 250, times by its latent heat, which is 2260. And then use this formula triangle to find out the time, which is the energy we've just calculated, divided by the power they've given us in the question. The answer is 188. A glass contains an ice drink on a warm and humid day. Water starts to form on the outside of the glass. What is the name of the effect by which the water forms? It is condensation. One end of a copper bar is heated to a high temperature. Which mechanism is responsible for the transfer of thermal energy to the other end? So this is to do with conduction and the movement of that sea of delocalized electrons. You're also going to have the vibration of the positive metal ions. So definitely not that, because it says only the lattice vibrations of copper ions and the movement of high energy electrons along the bar. Yes, that is the answer. The diagram shows a convection current caused by a piece of ice placed in a beaker of water at room temperature. Which row correctly compares the temperatures and densities at water points P and Q? So here, what's going to happen is that ice is going to cool the water, meaning that the particles get closer together so they get more dense and sink. So at P, we'd expect it to be colder and denser. And then as it warms up slightly when it gets to Q and the particles spread out, it becomes less dense and warmer. So the temperature at P, I've already said, will be lower than at Q. Density will be higher than at Q, so the answer is C. The diagram shows a wave. Which row is correct? The amplitude of the wave is the distance from a peak to the equilibrium point, so it's 1 centimetres. What is the wavelength? It's the distance between two peaks. That's 10. That's 2, so it's 8. The answer is B. A sound wave is created by a loudspeaker that vibrates backwards and forwards 96,000 times per minute. Right, I can already see we're going to have to work out frequency. The speed of sound is 320 meters per second. What is the wavelength? So this is our equation, which states that speed equals frequency times wavelength, but we need the frequency. Remember, frequency is the number of waves per second, so we need to do 96,000 divided by 60 to get it from 1 minute to a second. So the frequency is 1,600 hertz times by x, which is what we're after. We know the speed is 320, x equals 320 divided by 1600. The answer is A. A card is placed in front of a plane mirror so that its label is facing the mirror as shown. The label is shown. How does the image of the label formed by the mirror appear to the observer? Wow, gosh, you're really going to have to juggle this. So if that is kind of imprinted on this side and it's being reflected, then you'll see a kind of mirror image of it. So it needs to kind of be back to front. So almost like this. And so the answer here is C, because look, that's what I've drawn. A thin converging lens can produce both real and virtual images. Which row describes a real and virtual image? So first of all, you must have rays converging to form the image. And if it is virtual, it can't be projected onto a screen. The answer is B. The speed of light in air is 3 times 10 to the 8 meters per second. The critical angle for light in a transparent plastic material placed in air is 37 degrees. What is the speed of light in the plastic material? So what you want to do here is use the relationship sine c equals 1 over n, because you want to find n. So you put sine the critical angle, which we've been given, over n, cross multiply to find the refractive index. So that's 1.66. And then in order to find the speed of light, what you have to do is you take the speed of light in air. Unfortunately, this is just something you have to learn, and then you divide it by that refractive index. And then in standard form, that's 1.80 times 10 to the 8. So the answer here is A. Which part of the electromagnetic spectrum is used by a remote controller for television? This is a communication type of EM wave. It is actually infrared. The answer is A. Which statement correctly compares radio waves and X-rays? Radio waves have a longer wavelength. That's true. No, they travel at the same speed, so that's false. Radio waves have a longer wavelength and travel at the same speed. Correct. 27B. A student counts how many iron pins an electromagnet picks up when its power supply is switched on. Then she counts how many pins are picked up when the power supply is switched off. She repeats the experiment using cores made of different materials. The results are shown. Which core is made out of soft iron? So I'd expect with the soft iron core that you'd pick up more iron pins. And then because iron is a soft magnetic material, it really loses its magnetism as soon as the current's switched off. So I'd expect there to be 0 pins picked up with the power supply off. So the answer is D. A plastic rod is brought near to a small plastic sphere suspended from a stand. The sphere is repelled by the rod. Why is this? So repulsion is when they have like charges, so the answer is A. Which unit is equivalent to a volt? The way you do this is by considering equations that have voltage or potential difference in them. So voltage is current times resistance, which means it's the same as A ohms. That's not an option because that's not the same, so we'll look for another equation. Here's PIV, which states that voltage is power divided by current, so that's watts divided by amps. That's also not there. Now let's look at EVQ, which states that voltage is energy divided by charge, so that's joules divided by coulombs. Phew, we're finally there, it's B. A resistor converts 360 joules of energy when there is a current of 3 amps in it. The potential difference across the resistor is 6 volts. For how long is there this current in the resistor? You want to use E equals IVT. Energy is 360 joules. Current is 3 amps. The voltage is 6. We're after time. So to find time, divide 360 by 18 to get 20. The answer is B. The 4 circuits shown each contain 4 diodes. Remember, diodes only allow current to flow in one direction only. In which circuit is the direction of the current in the resistor always from the red terminal to the black terminal? So it needs to be going from in this direction only. So we can actually trace it through. So if we come along this route, current flows in one direction only. So it will come down here, then it will come down here to the red terminal, across to the black terminal, back up, and then it can go either along this way or this way. But the point is it is going red to black, which makes me think it's A. Let's check B. Here comes the current. It's coming down here, and that means it's going black to red in this particular route, which means it can't be that one. What about if we took this direction, follow the direction the arrow is pointing? This one's good because it's going red to black, but what happens if we took this route up here? Well, that would be going black to red. And then finally, let's go down this way for argument's sake. That would be going red to black, which is great, but if we followed this route along here, then that would be going black to red, which isn't what we're after, so the answer is A. The diagram shows a circuit of 6 identical lamps connected to a battery. Which lamps are the brightest? You've got quite a confusing setup here because this here is a series circuit, a parallel circuit over here. So in all honesty, if you think about the energy flowing through the bulbs, most of that energy will be going through P, so the answer here is AP. Well, logic gates are no longer on the specification, so I won't be answering that today. There has been a specification change since June 22. A magnet is dropped vertically through a solenoid. This induces magnetic poles at both ends of the solenoid. Remember, a solenoid is a cylindrical coil of wire. Which magnetic poles are induced at position X in diagram 1 and diagram 3? So we're comparing these two here. The thing about this question is you just need to know a very specific part of the specification, which states that a south pole on the magnet develops the south pole at the beginning of a solenoid, and at the other end, after the magnet has been dropped through the solenoid, a south pole is generated opposing the north pole moving away. And so what can we infer from that? Well, it means that up here, X is going to be a south pole, and then when that magnet drops out, it will now be a north pole. The answer is C. Which transformer can change a 400 volt alternating current input into a 15 volt alternating current output? So you want this, it's voltage primary over number of turns primary equals voltage secondary over number of turns secondary, then sub in all the values. Let's put voltage secondary as our X. The number of turns primary for A is 800. Number of turns on the secondary is 40, so solve that for X. So X is 12 in this case, which isn't what we want because we want 15 as our answer. Let's try another one. So it's not A. What about B? This time we have an output potential difference of 6, so it's not B. Now we have an output of 1.5 volts, so it's not C. Always best to check. Oh, classic. There's our final answer. It's definitely D, but it did take quite a lot of maths. What is the purpose of the split ring commutator in an electric motor? What it does is it switches the direction of the current every half turn in order to ensure that the motor keeps turning in one direction, which is why the answer is D. How do the sizes of the two nuclei produced in a nuclear fission reaction compare to the size of the original nuclei? So we're producing two smaller daughter nuclei. So the answer here is C. Which statement about the radioactive decay of a substance is correct? It cannot be predicted when a particular nucleus will decay. I like that. Placing a radioactive substance inside a lead-lined box prevents it from decaying. No, it'll just stop that radiation from causing harm. The decay always produces poisonous gases. Not necessarily true. The rate of decay increases if the substance is dissolved in water. Nope. The answer here is A. The diagram shows a stream of beta particles travelling in a line that passes between the poles of a magnet. In which direction will the beta particles be deflected by the magnet? So remember, beta particles are fast-moving electrons. So you can use Fleming's left-hand rule for this. Make sure you hold up your left hand. Your first finger should be pointing in the direction of the magnetic field, so north to south. The second finger shows the direction of this arrow here on the beta particles, and then work out which way your thumb's pointing. It should be pointing out of the page.